So when you're comparing fractions, you need the same bottom number. So when you're looking at a number like -3/8 and -5/8, you can compare them. Because it's like almost saying you're taking away 3 of these things, and you're taking away 5 of these things. So they have the same denomination. You've heard that phrase, denomination. Denominator means the same thing. They're all based on the same thing. So you're taking away 3 of these things, you're taking away 5 of these things. Which would you end up having more of? If you take away 3 or take away 5? If you take away 3, you'll end up with more stuff, right? So if you owed somebody $3 and you owed somebody $5, overall you'd have more money if you just owed them 3. So the less money you owe, the more you have. And the same idea here when you have a 3/8 and a 5/8. If you have 3 of these things and somebody else has 5 of these things, who has more? This guy has more. So you can compare these things because the bottoms are the same. So again, you can think of it as you have $3, $5. Use whatever you want for the bottom number. It doesn't matter. You could use houses. If you have 3 houses, 5 houses, who has more houses? It has 5. Now, that's easy when you have a common denominator. But what if we had different ones? So let's just say these two numbers, 2/3, 8/12. Like 2 3s or 8 12s, what does that mean in terms of 3s? Well, I don't know. So what you got to do is make them both the same. So the key idea is this. I want you to write down that you need to, in order to compare, you need the same, we'll call it bottom. They have to be the same. Now there are many ways you can do this. So I want to hear one of these ways. Yes, sir.
You could multiply by 4.
All right, so here's one idea. We'll look at the problem here. You could think of it like this. And you say, well, I can turn that into a 12. But how do you turn that into a 12?
Multiply.
So what should I do to the top?
Same thing.
So that's 8/12 and 8/12. Oh,
Just the same thing.
so basically, they're the same amount. They're equal to each other. So that's one way you could do that. Is there another way you could have done that? You could also do this and say, you know what? I can turn a 12 into a 3. Well, how do you turn a 12 into a 3? Well, you have to divide by 4, and hopefully you can divide the top by 4. Oh, you can. So 2/3. What's 8 divided by 4?
2.
Oh, and again, they're the same amount. So you can either make one bigger or the other smaller. But now this worked out here because I could divide 8 and 12, but what if I had this?
It wouldn't work.
You could say, well, that's 2/3. And when we're just comparing numbers, actually you could still do that. It's a little bit more work. What's 12 divided by 4?
3.
How many 4s go into 7?
3.5.
2. 1. 1.
2.5.
1.
1.
2.5.
1.
1.
How many 4s can fit inside of a 7?
1.
Only 1. How much is left over?
2.
2.
3.
A half.
3.
7.
Yeah, 3.
3.
The rest.
Oh, so your answer is 3. Now I'm just going to ask you, which is bigger, 2 or 1 3/4?
1 and 2.
2 and 3. 2 and 3.
I hear a lot of, I'm asking a question and I hear lots of different things that I'm not asking. I'm asking, which is bigger, 2 or 1 3/4?
2.
2 is bigger than 1, isn't it?
Yeah.
So we could, so we still can do this, but it gets a little confusing when you have fractions in fractions, doesn't it? So in this case, to make it easier on yourself, and because there was a lot of blah, 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 instead of dealing with that, pay attention. Instead of dealing with that, you could say, you know what? I can turn that into 3, but I can't, if I divide that by 4, I can't divide that by 4. So in this case, I'll just mess with this guy. That's 8 over 12 and 7 over 12. And this is a little bit easier. Which is bigger, 8 or 7? 8. So there you go. You still get the same result. So the idea is this. You need to have the what?
Same bottom.
Same bottom, or a common denominator. Common means same. Denominator, in this case with fractions, means bottom. Which is bigger? 8 over 13 or 1 and 1/4? Which is bigger?
1/4. 1 and 1/4.
The same.
They're the same?
Yeah.
Well, let's think this through, because I hear this is big. Well, I hear 1/4. Then I hear 1 and 1/4. Then I hear this is the same as this. Well, I'll ask this. What does a fraction mean? All right, so this is part of the total. When you have a fraction, I have 8 out of that thing there, right? Now, do you even have the whole thing?
No.
So by just looking at this, you don't even have a whole. Well, I don't care if I can make one, but what I have here, I don't have a whole thing, right? I don't even have one whole. What does that mean right there? That 1 means you have one whole. So do I even need to do any work here?
No.
Why not?
Because you have 1 whole extra.
Because I have a whole right here. Do I have a whole thing here?
No.
No. So who has more? This guy's got more. You don't even need to do any work. You don't need to find common denominators. You just need to understand what a fraction is. So if you enjoyed this video, please subscribe and watch some more. You can watch this video. You might enjoy it. My latest video is right over here. Please enjoy your day and keep on mathing.
Subscribe and tap the bell.
All right, what I want you to work on right now